Because there was some confusion and I didn't realize that you guys had been talking about the shell method, I wanted to talk through this idea here, looking at the washer method versus the shell method, and talking through the shapes and what you want to do with that. If you don't feel comfortable with the shell method, maybe stick with the washer method. It's going to work just fine. So say we have y equals x squared, and here's x equals 2, and we're rotating around the y-axis, and we're stopping at the x-axis. So we have this shape. It ends up making kind of a cylinder. I say that like the ice cream container, and you've scooped out most of the ice cream. Okay, and we want to evaluate this. We're going to evaluate with the shell method and with the washer method. With the washer method, you have a washer, right? Which is basically a very flat cylinder with a small cylinder taken out. So like a circle with a circle inside taken out. And that's if we cut it across here, and we want a little bit of thickness of our washer, and that's in the y direction, so that's dy. So we're going to be looking in the dy direction. The thing to remember about this washer is its shape. Its shape is a circle with a circle taken out with a little bit of thickness. So I have pi times the outer radius squared minus pi times the inner radius squared times a little bit of thickness to make it three-dimensional. So in terms of my integral, I've got that. I've got pi times the outside radius, which in this case is constant at 2 squared, minus pi times the inside radius. Now the inside radius is the distance from here to here, which is x. But because we're in dy, I want to do it in terms of y. So since y equals x cubed, I'm going to use x equals y to the third. So I have y to the third squared times pi. And I get 0 to 8 because I'm cutting these this way, and it starts at 0 and works its way up to 8. So I have this. I take the integral. I'm here. That's 4 pi y evaluated from 0 to 8 minus 3 pi over 5 y to the 5/3 evaluated from 0 to 8. That gives me 32 pi minus 32 pi times 3/5. So that's 2/5 of 32 pi, which is 64 pi over 5. Okay, that's using the washer method. When I'm using the shell method, I'm using a different shape. In this case, my shape is a shell of a cylinder. It's a cylinder with just a little bit, it's empty in the middle with a little bit of thickness. So the value of that is this circumference times the height of the cylinder times a little bit of thickness. Well, a circumference is 2 pi r, so then 2 pi r times the height times the thickness. So in this case, 2 pi r is going from here out, right? So that's an x value. That's an x value. My thickness also, if I'm looking at this cylinder, my thickness is also a little bit of x value. So I have my x for r, and I have my dx for my thickness. My height of the cylinder, down here I have very short cylinders, up here I have very tall cylindrical shells. So my height is based off of this function, which happens to be x cubed in this case. So I have x cubed. And I'm going from 0 to 2 because now I want my x values to range from the smallest radius, which is 0, up to my biggest radius, which goes out to 2. So that's why it's 0 to 2. So I take this integral, I get 2 pi x to the 5th over 5, evaluated from 0 to 2. So that's 2/5 pi times 32. That's 2 to the 5th, 32. So I get the same thing, 64 pi over 5. So we see we got the same thing. So that's the difference. You got to think in terms of shape. If you're doing the shell method, you want this type of shape, right? You want a cylindrical shell where your values are based on the circumference and the height and a little bit of thickness. If you want on a washer, you're doing a circular shape. It's a cylinder that's filled, and you're cutting out a hole. If it's a disc, it's just, you're not cutting out the hole, so you're not subtracting anything. So it's pi r squared with a little bit of thickness, and that's your, in this case, dy. Okay. So you can see how these use different shapes that get the same answer. This one, because it's revolved around the y-axis, and you're nesting these shells like Russian dolls, nesting them inside each other, and you're expanding in the x direction. So that's why it's dx. Here you have a bunch of washers that you're stacking on top of each other, so you're moving in the y direction, so that's dy. And hopefully that helps clear up a little bit of the confusion between those two.